Today attendance is very poor, only 11 students. It should be nearly 30. Can you remember that? Did we discuss this part or not?
Sir, we didn't discuss this slide.
Yes, yes. I think we'll have to start from here. Okay, then last week we had a discussion about uh, continuous probability distribution, where we learn normal distribution. The normal distribution you can use to calculate probability related to discrete, continuous random variable. Then to calculate probability related to discrete random variable, you can use Poisson distribution. There are two distributions. One is binomial, we already discussed it. The other one is Poisson distribution. This is a very useful mathematical model. There are many applications in Poisson distribution. Let's say, as example, you want to do a study about number of customers visit ATM machine. Number of customers visit ATM machine. Let's say time period, let's say 4 to 6 p.m. This may be the rush hour. Then let's say as a manager, you want to know what is the probability that, let's say, more than 20 customers visit ATM machine during 4 to 6 p.m. Or maybe what is the probability that 20 customers visit ATM machine during 4 to 6 p.m. These type of probabilities you can calculate once you learn Poisson distribution. As a bank manager or maybe operational manager, sometimes you can get some data related to ATM machine usage. They may have record. With this record, if you can find, let's say, 30 days data, that means last 30 days, if you have data related to number of customers visit ATM 4 to 6, maybe 4 to 5, any time duration, then you can calculate the probabilities using Poisson distribution. We can use Poisson distribution when you are interested in the number of times an event occur in a given area of opportunity. Here, given area of opportunity mean time period. Given area of opportunity mean time period. An area of opportunity is a continuous unit or interval of time or volume, such as area with more than one occurrence of an event can occur. What has happened? Then these are the examples for uh, the cases we can use Poisson distribution. Number of accidents occur in a road per day. Number of births occur in a hospital per hour. Number of mosquito bites on a person. Number of computer crashes in a day. Then you can apply Poisson distribution when these conditions are satisfied. Okay, you can apply the Poisson distribution when these conditions are satisfied. You wish to count the number of times an event occur in a given area of opportunity. That means your interest is to count or observe number of times an event occur in a given time period. The probability that an event occur in one area of opportunity is same for all area of opportunities. That means, let's say if you consider 30 days, okay, then we assume the probability is same for all these 30 days. Then the number of events that occur in one area of opportunity is independent of the number of events that occur in other area of opportunity. That means, let's say if you consider time number of days, let's say Sunday, Monday, Tuesday, any day, these all are independent events. The number of accidents occur in Sunday is independent from number of accidents occur in Monday. Then the probability that two or more events occur in an area of opportunity approach zero as the area of opportunity becomes smaller. Okay. That means, now let's say you consider time period 2 hours. Then you have certain level of probability. If you consider 1 hour, this probability will decrease. If you consider 30 minutes, the probability will more decrease. Then the average number of events per unit is lambda. That means the average number of, let's say, accident per day or average number of customers per day, we call it is lambda. Okay, now this is the mathematical model you can use to calculate probability. This is the mathematical model you can use. X is equal x, the x is our random variable. Lambda is expected number of events or average value. Then E, we call it is natural logarithm. The value is constant value. Then xi, that means this is the factorial. We discussed this one. This is equal n into n minus 1 into n minus 2 up to 1. Then in the Poisson distribution, we assume mean is equal to lambda and the variance also equal to lambda. The standard deviation equal to square root of variance. Then we can have one example. This is actually related to 2016. In Sri Lanka, we know there are many accidents happening in every day. In 2016, there are nearly 3,000 people died due to road accident. Then the total number of deaths is this much. Then you can calculate the average accident or average death per day. The average death per day is 8.2. Okay, 8.2. Then using this number, average value, we can calculate probability related to number of accidents per day. Okay. Number of accidents per day. Now you can check whether Poisson distribution is applicable for this event. Please read this slide and try to understand it. Then here lambda mean average number of accident per day. According to the given information, it is 8.2. Then x is a discrete random variable. In this case, x is number of accident. Number of accident occur in a given day. Then we wish to count the number of accidents occur in a day. The probability that an accident occur in a day is same for all days. The number of event, that mean accident occur in a day, is independent of the number of event that occur in other days. The probability that two or more accidents occur in a day approach to zero when the opportunity becomes smaller. That means you consider a day, but let's say if you take the 1 hour, then the probability will decrease. Then this is the formula. Then let's say if you want to find probability of happening 4 accidents in a given day, you have to insert given information here. X is 4, lambda is 8.2, lambda in the lambda 8.2 to the power of 4. Then the answer is 0.0491. With your calculators or maybe with your smartphone, you can get the answer. But later I will explain how to get the value without doing calculation. We can get the answer using Poisson distribution table, like we did for binomial distribution. We can get the probability through the Poisson table. Okay, then we will move to another example. Please read this one. Birth in a hospital occur randomly at an average rate 1.8. Wow. What is the probability of observing 4 births in a given hour at the hospital? Average is 1.8. It is lambda. Then we want to know what is the probability that we can see 4 births in the hospital if the average is 1.8. Then you have to insert given information into this formula. Okay. You have to insert given information into this formula. E, we don't know value of E. In the lambda, value 1.8. In the lambda, 1.8. X is 4 divided by then you can see the answer 0.723. 0.723. Please check whether you can get the same answer using your maybe mobile phone or scientific calculator. Okay, then the second example, what about the probability of observing more than or equal to birth in a hospital? In a hospital, you are an hour at the hospital. That means more than two births, two or more than. Two or more than mean it may be 2, 3, 4, 5, any number. Then how to do this one? If you take more than 2, it start from 2 to 3 up to n. Then what is the left figures here? That means then we know probability is equal to 1, greater than or equal to is equal probability 1 minus x is less than 2. Less than 2 mean 0 and 1. 0 mean 0 birth, 1 mean 1 birth. So the more than 2 births mean we subtract these two probabilities from 1. Why we subtract from 1? That means the sum of all the probabilities should be equal to 1. Did you get the point? Now I can share with you the uh, Poisson table. Okay, it is in the chat box. The Poisson table is in the chat box. Check whether you can open it. Can you open it? Okay. I hope you can see the table? Hello, can you see
Yes,
the
I can.
table? Yes. Then now I am going to explain how to get the probabilities from this table. Okay. Now here you can see lambda. In the first row, given the lambda value. These are the lambda values. In our example, second example, the lambda value is 1.8. The lambda value is 1.8. Then we calculate probability related to 4 births in a given day. Now you can see here same answer. Then how to read this? From this, you have to find the lambda value. Then x, from x, is the answer. Then what is the probability that p x is, let's say, greater than 2? X is greater than 2. Just please send the answer into chat box. If the lambda is 1.8, what is the probability that x is greater than 2? Let's say another one. X is 0. What is the probability? X is, let's say, less than 2. Please send your answer into chat box for these 3 questions. First one is x is greater than 2, x is 0, x is less than 2. Yes, please send your answer into chat box. Yes, one has sent the answer 0.5372. What is that one? It is related to first one. Yes, how about others? I caught them. පාඩම් කරන්න බයෝටියක් ගන්න බය කරන්න. ඔව්. ඔල්ල මොකද දාන්න බාන්නේ ඒක. ඈ දන්නවා. ඒ දෙකක් ඒ දෙකයි බී එකක් ගන්න ඕනේ මෙඩිසින් ගන්නන්නේ. ඔව්. Hello. Yes. Sorry. Then the first one is actually greater than 2. Then greater than 2 mean you can easily calculate it. 2 greater than 2 is equal 1 minus x equals 0 and x equal 1. Then x equals 0 is this value, then the 1 is this, then 1 minus these two values, sum of these two values is the probability that we can observe more than 2 births. Then x equals 0 is very simple, it is 0.1653. Then less than 2 is sum of these two values, 0 and 1. I hope you got the point. Okay, then this is very simple. You can read the now table. If you have any doubt, you can raise before we move to our discussion. Okay, then the next example. Suppose we know that birth in a hospital occur randomly at an average rate 1.8 birth per hour. What is the probability that we observe 5 births in a given 2 hours interval? 1.8 is average for 1 hour. Then we can assume this is same for all other hours also. Then if the average is 1.8 for 1 hour, the average for 2 hours is 3.6. 3.6. Okay. Then the lambda value is now 3.6. 5 birth per 2 hour. The probability is this. This shows x is distributed with the lambda for one interval. Y is a distribution with k unit of interval. That means, let's say here 1, here 2. Then k is equal to 2, then lambda into 2. Okay, another example. Now suppose we know that hospital A birth occur randomly at average rate 2.3. In the hospital B, birth occur randomly at average rate 3.1. What is the probability that we observe 7 births in total from the two hospitals? Okay. The one hospital average is 2.3, another hospital average is 3.1. We want to see 7 births in total from two hospitals. It's like this. Then the distribution 1, let's say hospital A, hospital B. Then we can combine these number of birth from hospital 1 and 2. Then the lambda value also equal to sum of these two average values. Then in the hospital A, average is 2.3. Hospital B, average is 3.1. And the total average is 5.4. Then you can see the 7 birth. Then how to get the answer from table? The lambda value you can find 5.4, or maybe the nearest value. If you don't have 5.4, you can get 5.5. Then this side 7. And this is the answer. Check with the table whether you can get the same answers. Okay, then we will move to the last section of this topic. Now here I am going to explain how we can apply or how we can fit a Poisson distribution for real data set. Now in this example is related to number of accident in last 720 days. Number of accident per day, it may be 0, 1, 2, 3, more than. X is number of accident per day. It may be 0 accident, 1 accident, 2, 3, or more than. How many days we observe 0 accident? 395 days. How many days we observe 1 accident? 235 days. How many days we observe 2 accidents? 73 days. Okay. This is a given data set. Now we can check whether Poisson distribution is applicable or not for this data set. This is the checklist. The event occur independently. That means the number of accident. And also it is a random event. The probability of an event occurring in a given time interval does not vary with the time. That means if you consider probability in a day, it's same for every day. Then to fit the Poisson distribution, you have to do only one calculation. Calculation is you have to calculate the average number of accidents per day. It is the lambda, average number of accidents per day. How to calculate average number of accidents per day for this data set? It is equal sigma fx divided by sigma f. Sigma fx means 0 into this is the f, sorry, this is the x, this is the f, x. 0 accident, how many days? 395. 1 accident. Then we divide it by 720. Then the average number of accidents per day is 0.6. 0.6. Then if I ask you to calculate what is the probability that we have 0 accident, what is the probability that we have 1 accident, what is the probability that we have 2 accident, 3, like this, you can check it. Please check with the table. Then if you check with your table, you can see the probability we are having 0 accident, 1 accident, 2, 3, 4, 5, more than 5. Then here you can see expected frequency. What do you mean by expected frequency? According to the given data set, the 0 accident, how many days we have? 395 days. Then the 1 accident, how many days? We have 235 days. These are we call actual values for actual frequency. Then what is the expected frequency? Once you construct your model, you can predict expected frequency. Now in this example, your sample size is 720. You have considered 720 days. In these 720 days, you have observed 0 accident, 395 days. It is the actual value. But according to the model, the expected number of days with zero accident is 395.1. 5488. Okay. Then this is 3951. Then the actual value is 395. Then the expected value is very similar to actual value. If the expected value and actual value are similar, or there is no big difference, then your model is good. Then your model is good. Then the second one, let's say probability is this much, then the expected value is this. How to get this one? Then you multiply 720 by 0.0303. Multiply by 0.3293. Okay, this is the way to hit a Poisson distribution. I hope you got the point. Then we can do one more topic we have here. So now I am going to explain how you can calculate probability using Microsoft Excel. Let's say number of birth is 1.8. Then the value of X may be 1, 2, 3, 4, 5, any number. Poisson distribution. X is this value, then comma, mean.
Can't see the screen.
Hello? Can you see the screen?
No, sir, can't see.
Sorry. I think now you can see.
Yes.
Yes, okay, sorry. Then here I am going to explain how to calculate probability using Microsoft Excel. Then the average number you need, let's say it is 1.8, X is 1, X value 1, 2, 3, 4. Then you can type here equal sign, Poisson distribution, mean value, comma, X value, comma. Then you have two options. cumulative distribution and probability mass. We will select probability mass. Then close the bracket. Then this is the probability. We are having one birth if the average is 1.8. Then here this value is constant, then you can put here dollar mark. Then you can click and drag. Oh. Oh. Right. Constant value is E. Then you can see the probabilities. Then let's say you want to see the probability x is greater than 3. With the cumulative function, you can easily calculate it. Poisson x comma mean comma then we select cumulative. Then this is constant value. Okay. Now this is the cumulative one. Okay. Okay, now you can see the difference between cumulative one and probability mass function. Now here this is the 0. Then if you want to find greater than 3, then the greater than 3 mean you have to subtract less than 2. 1 minus this value. This value shows the x is less than or equal. Or we can say x is less than or equal to. I hope you got the point. And also we can see the shape of the distribution with these values. Now you can see the shape of the distribution is like this. The distribution is then you can see what will happen to the distribution if the average value increase. See, when the average increase to 1.8, the distribution is like this. If the average is 1.8, the distribution is, we can say, right skewed. If the average is high value, the distribution is left skewed. That means the shape of the distribution, shape of the probability distribution is depend on the lambda value. If the lambda is high value, the distribution become left skewed. If lambda value is lower value, then the distribution become right skewed. Okay, now this is the end of discussion related to Poisson distribution. I hope you learned something from today's session. Still, there are 10 students, only 1 student left, I think, on the way. Earlier, there were 11 students. I don't know why the attendance is so poor. Normally, there are, I think, nearly 30 students. No? Okay, however, I'm going to wind up the session here. Then the next week, we will start new topic. Shall I wind up?
Okay, sir. Thank you.
Okay, bye.
sir.